Okay, so we're going to prove that A intersection B complement is equal to A complement union B complement for any sets A and B. So what we're going to use in order to prove this is, of course, the definition of complement, the definition of intersection, and one of the De Morgan's laws for propositions. So let's go ahead and start the proof. Okay, so we're going to have X be an element of course, A intersection B complement. So we know this means that X is not an element of A intersection B. So what this means is that it is not the case that X is in A and X is in B, right? So we know this statement is of the form not P and Q, right? It is not the case that X is in A, which we're going to have as P, and X is in B, which we're going to have as Q. So this is of the form of this. And by De Morgan's law of propositions, we know this statement here is logically equivalent to X is not an element of A, or X is not an element of B, because this is of the form not P or not Q, which of course we know not P and Q is logically equivalent to not P or not Q. And then of course, we just use the definitions here. X is not an A, that's the definition of complement. That means X is an element of A complement, or X is an element of B complement, right? And then the definition of union. This means that X is an element of A complement union B complement. So what we have is that for every X is an element of A intersection B complement if and only if X is an element of A complement union B complement. So if we have this statement here, we know that A intersection B complement is equal to A complement union B complement. And that is the proof.